Hello learners, welcome to Physics Form 4. We are still on the topic on thin lenses. I am your teacher, Mr. Nderitu. And last time we looked at image properties and how different images formed on a converging lens. Today, I want us to look at magnification and maybe try one or two examples on magnification. So we see that magnification F, it has two formulas. One, it can be defined as image distance, that is HI, now V, divided by object distance, that is defined as U. That is one way. Another way of defining magnification is by using the height, image height, that is HI, we divide that by object height, that is given by HO. So using those two formulas, I want us to try a small example where we are told that an object is 2 centimeters high. An object is 2 centimeters high. It is 40 centimeters from a converging lens. It is placed 40 centimeters from a converging lens. Next, we are told that its image is formed 20 centimeters. So this was the object, that is 40 centimeters. The image, its image is formed 20 centimeters from the converging lens. So the question is, calculate number one, the magnification. Calculate the magnification. And number two, calculate what we call the height of the image. The height of the image. So when we start with magnification, we first check what we are given. Number one, I can see that we are given HO, or the object height, 2 centimeters. We also have the distance from the object distance, that is U. U is 40 centimeters. And also the image distance, V, is 20 centimeters. And you have said M is equals to V divided by U. Therefore, magnification, therefore, for the first part, will be given as V, 20 centimeters, divided by 40 centimeters. That gives us a magnification of 0.5. We notice that there are no units since centimeters cancel, and we remain with 0.5 centimeters. Next, we look at, there are so many other examples that we can do, but we look at part B, the height. This was part A, magnification. The next one is height of image. Now for this one, I want to go back to the formula. We have said that magnification M can also be given by height of image divided by height of the object. So already I know the height of object and I know the magnification. So I come and say that 0.5 is equals to height of image over height of object, that is 2 centimeters. Cross multiply by 2 centimeters on both sides. And we can see that height of image is given as 1 centimeter. Height of image is given as 1 centimeter. So I'm saying we can try so many other examples, and I'll challenge you to look for more examples. But the next part I want us to look at, still on thin lenses, apart from magnification, is the mirror formula. The mirror formula, and it is going to assist us a lot in calculating questions involving, so the lens formula, not the mirror formula, lens formula. The mirror formula is found in Form 2, and I say that is a topic that is easily confused with this topic. So the lens formula goes this way: 1 over f is equals to 1 over u plus 1 all over v. It is very much similar to Form 2's mirror formula, but the only difference is that now we are talking of lenses, not mirrors, where f is the focal length, which we remember for lenses there are two. A lens can have a focal length on either sides. U is the object distance and V is the image distance. Something else we shall be using is what we call the sign. We shall adapt the sign convection. Convection, where we say real is positive. Positive. For example, in A, all distances are measured from the optical center. So we shall measure all distances from the optical center. For example, when I talk of F, I mean from optical center all the way to F. That's what we define the distance or the focal length. Number B, we shall be talking of all distances to real, all distances to real objects or images. Sometimes the lens can form a real image, are said to be positive. Finally, number C, focal lengths. The focal length of what we call a convex is positive, but the focal length of a concave shall be said to be negative. Is said to be always negative. So I have an example here that I would want us to do. It says an object is placed 30 centimeters away. An object is placed 30 centimeters away from a converging lens. So it will be converging, convex. It's a positive. Converging lens or focal length. Focal length positive 20. Remember we have said converging lenses have focal lengths that are positive, but convex are positive, but concaves are said to be negative. So this one is positive 20. Find the position. Find the position. The position and also find the magnification. Magnification of the image. That is a simple one. In the solution, we come and say that 1 over f is equals to 1 over u plus 1 over v. So what we are looking for, we have f. We also have object distance known as u. So we are looking for v. Therefore, I can reorganize the equation to get 1 over v is equals to 1 over f minus 1 over u. Therefore, we have this as 1 over 20 minus 1 over 30. That gives us 1 over 60. And therefore, v is equals to 60 centimeters. Because if 1 over v is 1 over 60, then it means v is 60 centimeters. Therefore, finally, the magnification is v over u. So I take 60 divided by, because they wanted the position and the magnification. So 60 divided by u, that is 30, to give us 2, which means it has enlarged. Now, we have come to the end of that part. We have learned about magnification and also a little bit about the lens formula. Next time, we shall be comparing lenses that we find out here to our eyes. We are going to look at the human